So here, Peter's holding a slinky. The slinky is naturally stretched out a bit by gravity. As you can see, the coils are closer together at the bottom, and further apart the closer they get to Peter's hand. The slinky is being pulled down by gravity, but it's being held up by Peter's hand. Now the question is, what's going to happen when he drops the slinky? This is a screenshot taken of Logger Pro video analysis. The light blue dots represent the top of the slinky and the dark blue dots represent the bottom of the slinky. As you can see, the bottom of this slinky is stationary for some time, even after the top of the slinky begins to fall.
When the coil is at rest here, when I'm holding it up, all the coils are like equally close together, but then when I drop it, it falls until they're farther apart, because as it falls and the distance between the coils increases, the spring force from the next coil up increases, so each coil simply falls until there's enough spring force to counteract the force of gravity and the other coils below it dragging it down.
Here's a slinky, and between every coil is some sort of spring force, and as you can see, the distance between the blue and orange is larger than the distance between the pink and green, and because spring force is equal to spring constant times the distance, the spring force here is larger than the spring force here.
Because the forces are balanced for each coil, this means that the acceleration for each coil is 0, i.e. each coil is at rest when the forces are balanced. This means that each coil stays at rest for as long as it experiences spring force from the coil above it. This is why the bottom of the slinky doesn't fall at the beginning when the top falls, because the coil above it has not yet fallen, so there's still spring force holding the bottom coil up. The coils fall one at a time and create sort of a chain